Chevy Volt example, and line 1 to 3 were right here. So if you can follow me along and then do the exercise together with me. So if you have this kind of table, then what you want to do is you want to first create X bar and then range chart. And if you create X bar chart first, then simply you want to use a function called average, as you know very well. And then it's going to create the mean of those values, sample values, and just copy it down like that. And then you have created X bar. And here you want to create X double bar. And X double bar, I said it's a mean of means. So average of averages will give you mean of that. So 201.875 is your mean of means, or X double bar. Now for R, you can do it manually, but I prefer using the function. So I'm going to do maximum minus, right? Maximum minus minimum of that. And you can calculate that range right away, and you just copy that down. Then you have range, and you want to also calculate the R bar, which is range, average of range. So let's do that. That's going to be this. So 25 is the average of range. And now we need to work on upper control limit. And upper control, I says X double bar plus A2 times R bar, right? That's what I said. And then center line is going to be X double bar. Now, lower control limit is X double bar minus A2 times R bar. That's a X bar chart. Now R chart, we can also calculate upper control limit and center line and lower control limit. And I said upper control limit is going to be D4 times R bar, and center line is going to be R bar. Oops. And lower control will be D3 times R bar. And the thing is, we need to find A2 and D4 and D3. And I said that these values can be derived from this table. So I'm going to copy this and bring it here. So we learned that A2, we have to look at the sample size, and sample size is not 8, but we have to go by the different process that we have. And that's line 1, 2, 3. Therefore, we can say that A2 is going to be, when sample size is 3, and A2 is 1.023. So 1.023 will be A2, and D4 here is 2.574, and D3 is 0. And now you are in the position of calculating everything. So you have that, and I'm going to just highlight them. And I'm going to calculate upper control limit is going to be X double bar times A2 times R bar, right? So that's my upper control limit. And I'm going to use a different color scheme so that it's easier for you to understand. So I have this X bar chart, and I found that something's not right. F11 plus, right? Plus J13 times G11. So then you have 227.45 as upper control limit, and central line is going to be the X double bar, and lower control limit will be X double bar minus A2 times R bar. So if you do that, you can quickly calculate upper control limit, lower control limit, and lower control limit. In the same way, let us calculate this. D4 times R bar, D4 times R bar gives you 64.35, and here's R bar. And D3 times R bar is going to be 0 times R bar. And I'm going to use this. So R chart values are over there. And now I'm going to visualize this process myself. And I'm going to use X bar like that, right? And go to Insert and Chart. I'm going to use Line Chart. Oops, something is not right. So Insert and Chart. Right, so line with markers, and this is X bar chart right here. So we know that X bar chart is right here, and we're going to draw the center line and upper control and lower control limit. So go to Insert and Shape and draw one line like that, and then upper control limit is 227.45. And before doing that, I see that the vertical marks are not up to 227. As a result, we cannot see everything. So I want to go and change that. So I'm going to double click, and we have major line, and maximum, I'm going to just say 227. Oops, what did I do? Okay, so maximum is 227. 227, minimum, let's say minimum is right now 176. So let's say 230 and 175. 175. Good. So now we see that the vertical axis has the proper values for this graph. And I want to add now upper control limit and lower control limit and center line there. So go to Insert, and I'm going to start with Shape, and here's the line, and 227. So it's still 227. Anyway, say the upper control limit is right here, and lower control limit is I'm going to just copy this line and then say it's 176. So it should be about here. So we can see that it's quite safe because it's far from control limits. And then center line is D4 to 201.875. So around here is going to be your center line. And you can add text, right? Text like text box like that. And then you can say, this is your upper control limit, upper control limit. You can use different colors like that and copy this text box. And here we come lower control limit, lower control limit. and center line. So I don't see any problem with this X bar chart. And as we have done before, oh, one more thing is this line. It says 1, 2, 3, 4, 5, 7, 8, and I want to change it to the time. So right click and go to select data, and I'm going to add the horizontal axis to time. So this is going to be yours. Oops. 29 and everything you can see right there. So somehow it took time to update. So you can change that and you can see what's happening with your X bar chart. You can do the same with R chart, right? So if I just do it quickly, R, I'm going to just select them and go to Insert and Chart. I'm going to choose bar chart with markers. And here's R chart. And let's change the vertical line. So we see the maximum has to be 64 and 0. So I'm going to just copy this line and 64. About here, central line, 25. About here, and lastly, 0 is the lower control limit. So we see that this part is not under control. So you can mark it using a text box like that. Right? And then change the colors, say to this, and fill, go to transparency, maybe at 70%. Can you see it? 80%. And you can say that this is not under control because of this point, right? So we see this is R chart, and R chart is not in control. So as a result, I can say that this chart, this process is not in control, although it has cutting edge equipment and people and everything. So that's how we draw R chart and X bar chart, and judge whether this process is in control or not. However, I want to ask you, now I'm going to just stop sharing and I'm going to ask you, what do you think? Do you think this is, are you satisfied with this process? That's the first thing that I want to ask. Are you satisfied with this process? Okay, so now here, look at here, at between 10 to 11, I see that the range is beyond upper control limit, which is not good from this perspective of putting everything under control. And you want to go back to 10 to 11 and see what's happening. So let's go to 10 to 11 here, line 1, 180 miles per hour. During this hour, I don't know how many cars they produced, but they test them all, and the average is 180 miles per hour. And line 2, 170 miles per hour, and line 3 is 240 hours per hour. So the range is now 70 because the maximum minus minimum is 240 minus 170. That resulted in 70, which went way beyond the upper control limit, which was 64.35. So my question is, what do you think about this issue that between 10 to 11, the range went over the upper control limit? Is it a good problem or bad problem? So let me stop sharing. So you get here, line 3, 240, line 2, 170, line 1, 180.
I'd say it's not a problem that the car's upper control limit is that high. I'd say the problem is the fact that the manufacturing process is inconsistent. So it's unreliable and you don't know exactly what type of product you're going to get.
Very good, Rocco. So, you know, it's a manufacturing process problem because it's not stable. That's what it says. If you look at X bar chart between 10 to 11, it was right below the center line. So it was not bad, right? It was right below the center line. You know, hopefully it was around closer to center line, but it was not too deviating from the center line. So in that sense, it's good. But when it comes to our chart, it's way above the upper control limit, and that's causing the problem. And Rocco is saying that the manufacturing process is not stable. As a result, it's bad. That's what he says. Any other comment?
We watched like a video last class. I don't know who exactly it was, but it was some kind of operations guy who was saying that the Chevy Bolt is consistently 230. And if we take that into consideration, the mean value is way under that. I think the average is like 201 high, 201.8.
Oh, Rocco, that's a great point, right? So, you know, that guy said it's a 230, right, miles per gallon. That was the promise that he gave out in the advertisement. However, we see the center line is only 201.875. It's not far from 230. However, it's not meeting the promise. So, you know, to make the promise fulfilled, what has to happen is the lower control limit has to be above 230 per mile, miles per gallon. So that has to happen. So lower control limit, you know, this entire process has to go far above 230, and somewhere over here it should settle, and that's what has to happen. However, it did not happen yet. The center line is lower than the promised value, and the upper control limit is also lower than that. So that's a huge problem that this business is facing right now. So Rocco, very good. So I'm not satisfied with this process because 30 miles per gallon of work need to be done in this manufacturing, and that's a big problem. Rocco, great job. Second thing that I want to mention here, if you go back to 10 to 11, if you go to 10 to 11 here, 180, 170, 240. So this one is 240, and this is 170. So I see that line 3, if you look at across line 3, this was the best performance line 3, and 240 shows that, oh yeah, you know, Chevy Bolt can perform very well above our promise, right? You know, the promise was 230 miles per gallon, but now it's 240 miles per gallon, and it was achieved by line 3. So I would say, oh wow, what did you do between 10 and 11? What did you do, guys, so that you achieve 240 miles per gallon rather than 170 miles per gallon? What happened to you? So they will talk to you, you know, we did this method, we worked together with, so they will give some reasons for that, and you will be able to find, oh yeah, you know, can we really replicate what you have done so far? Somehow we can achieve that 240 miles per gallon rather than 230 or 170. So you may want to go back to line 3 team and, you know, investigate what happened during that hour and try to adopt and improve on their practices. Now, if you go back to line 2, you know, you see that line 2 has been doing very good, 210, 215, and so forth. And this is the lowest performance that they produced at the time. And I know line 2 is quite a consistent team, and what happened to you? I want to know about that. And see somehow there was a malfunction in our conveyor line or equipment, and you want to take a look at that and improve upon it, that you need to do. So I would say this is both good and bad problem, because I see that you are able to achieve high miles per gallon promise right here in line 3. So that gives you a glimpse of hope about your production and delivering what you promised to your customers. So that's a great thing. But also you see a glimpse of despair here. Line 2 has been doing very well, but somehow it plunged into 170 miles per gallon. And what happened about that? So you want to investigate and avoid that process as much as possible. So I'm not working there, so I don't know exactly what happened there. But as a production manager or operations manager, you are stationed there and you work with the people. And when this kind of things happen, you want to discuss that, drill down more, and find out good things and bad things. And day-to-day, improvement may happen for your business.